Okay, now over on that little bar on the left there, see the thing that says note? Click on that. Awesome. Alrighty, and then 4 spots over in the center there is a little hand with a shape there. Click on that bad boy. And then click again. And now you've got some options. Let's have you draw a rectangle. It looks like a square, but it's a rectangle. Good, now choose your color before you get started here. You can make it blue, beautiful. All right, so close that, X that out there. Draw yourself a rectangle. Nice. Now, are you feeling fancies in your pantsies? Yeah, I like it over there, beautiful. Click on the rectangle again. Sorry, I meant the rectangle at the bottom, that was my fault. And see a little paint bucket there? Click on the paint bucket and pick a color you like to fill it with. Ooh, America. Exit out and click so. Nice. So now you have a red rectangle outlined in blue. Outstanding. Let's give it up for that so far. How would one find the area of that rectangle?
Multiply the base times the height.
Are we all in agreement?
Yes.
Awesome. Easy? Yes. Okay, so make up an example for the class. You might use your calculators, by the way, depending on how evil he is. As he laughs maniacally. You dog! How about some units? Love it. Good. Okay. Now what should we do?
Multiply.
No.
What?
Give us the problem. What should we do with those?
Find the area of the rectangle.
Beautiful. Find the area of the rectangle, please, for Ethan.
It's a big rectangle.
Ethan, you're evil.
Does everybody agree?
Yes.
Yes.
All right. So what is it?
10,000.
10,000.
Where do I write it?
Wherever.
In the middle.
Dude, you're driving this
Right in
bus.
the middle.
Oh, that's pretty.
674.59106.
Oh.
Undo is the arrow in the middle, down at the bottom. Yep, there you go. So we got rectangles under control? Good, they're boring. Let's move on to something new. In the lower right-hand corner is a plus button. Okay, and then let's draw a new figure. How about a parallelogram? Oh, yeah. Uh-huh. Okay. Let's not color it in yet. Let's do something fancy. Change to the segment tool.
Which one is that?
So click on the parallelogram thing that you just did, and then you'll see a segment. There you go. Uh-huh. And then X out of that. Draw a line, or sorry, a segment from the bottom left-hand corner, perpendicular to the top side. Pretty good. Okay, now we're going to get fancy. Are you ready for this? Get your paint bucket again. I'll be out of a job. Okay, pick a color. What are you going with?
Green.
Green. Okay, so color in the triangle. Green. Ooh, Joker colors. Very nice. Paint bucket again, but change the color. Now color in the other stuff. Nice. Okay, good. Pretty cool. We can do that with any parallelogram, can we not? Can we not?
Yes.
We can, good. Grab see the arrow thing there? Yep. And grab the green triangle. And what would one do with that green triangle? Oh boy, he's a step ahead of the game.
Why doesn't it work?
It is, there you go, you got it. Okay, now click on the original parallelogram, pink thing. Hit the trash can. Gotta do it quick before it fades away. There you go. What shape has he created?
Rectangle.
Rectangle, which we already know we can find the area of, right? Need the base and the height. Okay, so hit the back arrow a little bit. Okay, one more. Put that triangle. Good. So then go back to the original parallelogram. Where's the base in that parallelogram? Yep, that bottom thing. And where's the height? Good. Now notice the height is a perpendicular distance. It's not the side running down the edge of the parallelogram. It's the perpendicular segment. Okay, so we can turn any parallelogram into a rectangle, and therefore we would use the same example there of doing base times height. Okay, now you get to do an example. So let's delete the blue, the green, and the extra pink segment. I think that'll work. Give it a shot. It will not. You gotta go to the arrow. Well, that'll work too. Yep, one more. Bingo. All right, give us an example now.
So just like walk you through how to solve it?
No, just give us some numbers. We'll solve it.
Oh, all right.
Emily and I are all over this. Beautiful. Okay. What? I don't know. Is that solvable?
No.
I like it. All right, that's solvable. Let's go, girl. Well, how big is that angle right there? Just no, the one next to me. This is awesome. That's a good example. Feel free to circulate around the room to make sure people are on task. Check some answers. There you go. If they're not working, give them a stink eye.
What's the answer?
Do your work.
I already finished.
What is it?
'Interesting.
Something like that.
Yeah, it's close to that.
Oh, I did.
Oh, wait. Oh, wait. Oh.
300? Okay. 110 plus
I don't know, I'm pretty confident.
I got
How do you do
So what I was like, was it find like this? So if you have that, this angle is 110.
You know how to do that?
I have the answer.
You know how to do it though? Because if not, you can ask somebody to
It's
do
like
it.
supplementary.
That's
And
how
then
you
I
know
just
when you
like
don't
the
know how
sign
to do
of like the right
Have
triangle.
somebody else do
It's
something.
the easy way out.
Okay, so like I technically did it right.
I technically did it right, but I got the wrong answer.
You can go in the hallway.
Right. Technically, I ran a marathon, I just never showed up.
Okay.
Is everybody good?
Yes, sir.
Yes. Okay. Would anybody like to come up and demonstrate how you completed the problem?
I realized I did.
I'll do it.
Oh, Lily's up there, wow. Wow.
What did I do?
She's fine.
That's probably wrong, man. He was right.
You can't get that close to the board when you're writing. I mean, you don't have to back up into the back of the room, but you can't lay your arm up on the board either. Remember that when you're calculating the area of a parallelogram, you need the base and the vertical height, not that slanted height. That's why we needed the angle, which allowed her to calculate it that way. Emily and I did it differently. We dropped an altitude from the other corner. Yep. And we, wow. And we knew, sorry, I should, my bad. Sometimes things just, okay. And so we knew that that was a 90-degree angle, and since the whole thing is 110, we knew that that little angle down at the bottom was 20. Yep, and that made the other angle up at top 70, just like Lily had, and then we solved law of sines to find h on the other side. And remember that h is the same anywhere. Okay? Good? I'm going to take over because the next part's a little ugly. Let's give it up for Ethan, huh? Okay, let's, so we're good on parallelograms or rectangles, yes?
Yeah.
All right, let's talk about trapezoids.
Base plus base.
No, that's like, she heard square root. That's not a word.
Okay, so here's a trapezoid. And we've talked about these before, right? You know what a trapezoid is?
Yes.
Yeah, because we did quadrilaterals already, right? Okay, good. Two things we're concerned about in this trapezoid. One is B1 and B2. It's got two different bases. The bases are the parallel sides. And then there's a height just like we had in the parallelogram. So our height would be this vertical. You know what? I can do that better. We'll make it all fancy. The height is that perpendicular distance between the bases. Okay, and we want to find the area of that. Now, that happens to be an isosceles triangle, and isosceles trapezoid. And if it's an isosceles trapezoid, you can handle it differently. However, they're not all going to be isosceles. So what does happen with an isosceles triangle is it allows you to do the following. Whoops. Come on, I can do this. There we go. There's a duplicate, yes? Okay, do you agree those two are identical? Yes, because I made them identical. Now, if I take this guy and spin it around, and then slide it over to here, what shape did I just create? Parallelogram. And we know how to find the area of a parallelogram. We have to find the area of a parallelogram by using the height and the base. How long is that base?
2B2.
Not 2b2.
B1 plus B2.
b2 plus b1, because if that's b1, this becomes b1, this is b2, so this whole distance is b1 plus b2. Okay? Which means the area would be
B1 plus B2 times height.
say again?
B1 plus B2 times height.
b1 plus b2 times the height, almost. That would be the area of this whole thing, but we only want half of it, so we got to throw a half in front. And when you're finding the area of a trapezoid, you're not going to duplicate it every time, spin it over and put it next to it. It just gets us to this formula here. And like a lot of the area formulas we've done, it would be nice if you were given the height, the base 1, base 2, and calculate the area, but that won't always be the case. For instance, let's suppose we have a trapezoid that has an area of 250 centimeters squared. It has one base of 10 and a height of 7. Find the second base, please. Do a little bit of algebra there. You can have this half. You get the other half. Because you both solved it differently, I like to show both. Go ahead. I think you can actually do it at the same time. Let's see what happens if you try. Worst you can do is break the board. Probably $6,000, you're okay.
You wanna break the board?
Nice.
Oh, cool.
Hopefully they both get the same answer.
Oh no.
Whoa.
I multiplied by
I don't know, did I mess up? She did.
Wait, how do you do? Can I do the?
Yeah, sure.
Or should I try and erase it? Okay, there we go.
Alright.
'Cause I didn't want to. Oh no.
It's a back arrow.
Back arrow.
Oh. That's it.
Again?
Okay, that's not gonna work.
Oh.
The arrow.
Could have set a timer.
Okay, we got the whole thing. Where do I? Oh.
Beautiful. Okay, good, they both got the same answer. I'm hoping that's what happened. Two different ways to solve the problem. Which one's better?
Which one's what?
Doesn't matter, yeah. Whatever works better for you. So our son started by multiplying the 1/2 times the 7 to get 3.5. Then he distributed the 3.5 to the stuff in parentheses. Move the 35 to the other side, divided by 3.5. Done. Isabel multiplied both sides by 2 to get rid of the 1/2. Then divided by 7, and then subtracted 10. Same answer. Two different ways to solve the same problem. When you plug in base 1, base 2, and height, that's easy. This is a little bit more challenging, looking for one of the other variables. Questions? That's all we got for tonight. So we're getting close to wrapping this up with area, and then we're going to transition from area into volume. Tomorrow we're going to talk about kites and rhombi, but today we've just got parallelograms and trapezoids. Let's give it up again for Ethan. Nice job.